Hey, this next video I have is solving systems of equations using substitution. And also check out the other two videos I have using different methods.
Okay, let's get started. So here we have one problem. This is a system of equations. I have two equations and I want to figure out the solution. That's where the two lines cross. So I'm going to use substitution for these examples, and this problem lends itself to substitution because I got x on one side and x equals y plus 3, so x is 3 more than y. I'm going to take that and I'm going to substitute it in for x in the second equation. So writing that, I get y equals this y equals 4x. So in place of 4, like I said, I'm putting y plus 3. And then the other plus 3. Now, what I have here is an equation with y's and numbers but no x's. So I know I can solve this equation for y and figure out what y is. So first thing I'm going to do is distribute this 4. I got to multiply the 4 by y and then the 4 by 3, so I get 12 plus this last 3 here, and I can collect my terms or combine like terms. And now I'm on this step. Well, I want y by itself, so to do that first I want to get all the y's on one side. So since there's nothing else but y's on the left side, I'm going to subtract 4y here, and I got to do it to both sides. So y minus 4y is going to be negative 3y. And on the right side I'm left with 15. Now if I divide by negative 3, one negative, if I divide by negative 3, I get y equals negative 5. So that's only one part to the problem. I also want to figure out what x is. So I can take this number for y and put it into either one of these equations. I like the top one because it says x is 3 more than y, and y is negative 5, and x is 3 more than that, so I'll add 3 to it and I get a negative 2. So altogether, the best way to write this answer is as the ordered pair negative 2, negative 5. This is the ordered pair. It can be represented on the graph as a point on the graph, and it's the point where those two lines, this line and this line, cross, and it's the solution to our problem. Let's do another one. Now the problems don't always look like this, but this is a easier problem, and then I'm going to work my way to harder problems. So again, I got x equals 2y minus 4, and I'm going to take that and put it in for x in the second equation. So I get y equals 8 times 2y minus 4 plus 2. Now I distribute that 8, so 8 times 2y and 8 times negative 4, so y equals 16y minus 32 plus 2. I can collect my terms. Negative 32 plus 2, I get a minus 30 there. And now I can subtract 16y. I want to get y on the left side and only on the left side, so subtract 16y on both sides. On the left side I get negative 15y. On the right side I get negative 30. Now I can divide by negative 15 and y will be by itself, so it'll be solved. So I get a y on the left side. On the right side, 15 goes into 30 two times. I get a negative divided by a negative, which is a positive, so y equals 2. Now remember, don't pat yourself on the back yet, because I need to know what x is too. So I'm going to take y equals 2, my answer, one part of my answer, and put it in for this equation. So I put it in where I see y, I put 2. So 2 times 2 minus 4. So I don't need these parentheses anymore. So you can see I take this 2, the one in this lighter blue color, and I put it in for y. So it's 2 times 2 minus 4. Well, what is x? 2 times 2 is 4, so x has to be 0. X is 0. So again, my answer is best written as an ordered pair, where my x is 0 and y is 2. That's the point on a graph if you were to graph 2 lines. Now, some equations are not going to come just ready-made to substitute. So here in this equation, I can still use substitution. It's just that I have to do a couple steps before. So what I'm going to have to do is I'm going to have to solve for x or solve for y. So let's try solving for y this time. I got my y here. I'm going to eliminate everything that's happening on the left side until I only have y on the left side. So first thing is undo that being added to 2y by subtracting 6x, and I get 2y on the left side, and I'm going to write minus 6x first, or negative 6x plus 12, and now I get rid of the 2. It's with the y by dividing both sides by 2, and I get y equals 2 into negative 6x is negative 3x, 2 into 12 is 6. Now, let's call this equation 1 and this equation 2. Now I got equation 2 rewritten in a form that is useful to me. So I'm going to take this and I'm going to put it into equation 1. So equation 1 starts out 4x minus 3y. I'm not putting y, I'm putting negative 3x plus 6, and that equals 8. Now here I can solve for x. So when I go to solve for x, I'm multiplying the negative 3, because this is a negative 3 basically, by both of these terms. So I get 4x plus 9x minus 18. So what I want to do next is combine my terms. So 4x plus 9x is 13x. I'll put an 18 here because I was working too fast. Go back and look at that. It's not an 18, it's an 8. Add 18 to both sides. 18 plus 8 is 26, and 13x on this side. Now I can divide both sides by 13, and I get x equals 2, which is great. I'm going to have to do some erasing, but you can always go back in the video and see that part, which is great. But I'm not done yet, so now I'm going to come over here, and where that I got 2 for x, I'm going to put that into either one of these two equations and solve for y. So I think the second one is better, and think about why I said that. I said the second one is better because it doesn't have a minus sign, any negatives to deal with. So, and I could be wrong, but either one works, and I don't think it's too difficult. So I multiply 6 times 2, I get 12, and now I want to solve for y. So my first step will be to get rid of that 12, and I get 2y equals 0. Then my next step is divide by 2. I get y equals 0, so my ordered pair is the point 2, 0. This next one is another variation you might have. I got to substitute one in for the other, but it really doesn't matter which one I substitute. It'll replacing y. So y equals 2x plus 1. In this equation, y is over here, So over here I'm going to put 2x plus 1, and then the rest of my equation, or my second equation. Now I can solve for x. So I add 2x here, add 2x here, and I get 4x. Now why did I add 2x first? Because my first step in solving for x is to get x either all on the left side or all on the right side. And then I'll worry about just the numbers. So I'm going to subtract 1, I get 4 on the right side and 4x on the left side, and that will give me x equals 1. Now what do I do next? I take this 1 and I put it into either one of these equations. Think about which one you would choose, the first one or the second one. I'm choosing the first one because it has all positive numbers. So y equals 2 plus 1 is 3. Again, my answer is 1, 3. If you like this video, click the like button, share it, come back, watch it again, subscribe. Thank you.
Thanks for watching. There are 2 other videos you should check out, and I may do another follow-up. There's one more video I need to do where you have parallel lines and where you have 2 lines that are actually the same line, and how those show up when you're going to solve a system of equations.